Today we've put together some fascinating material about technological advances which range from how we can receive a delivery to how our brain understands the world. We're going to talk, for example, about the NeoClone. Have you heard of it? It's a super advanced robot with muscles and even artificial skin that feels touch.
Like something from a movie, right? And there's more. We're going to investigate how scientists are using lasers to basically induce illusions directly in the brain. This raises some very profound questions about what we really see, and bringing it more into our daily lives, we're going to see how Salvador, there in Bahia, already has a huge drone route making deliveries right in the middle of the city.
In addition, there's a tiny device that can show the brain working in real time, even while in motion. And to wrap up, humanoid robots, who they say are seeking empathy, and also autonomous military drones acting in a swarm. Our mission here is to try to understand these technologies, what they truly mean, and how they are already, reshaping our world and even our idea of it.
Well, let's start unwrapping all this, and we'll begin right here in Brazil, more specifically in Salvador. It seems that the logistics of the future are already flying there, over the Bay of All Saints. We're talking about the largest urban route in the country for cargo drones that fly beyond the pilot's line of sight.
That acronym, right? BVLOS. Right. BVLOS. Beyond Visual Line of Sight. Exactly. It's 40 kilometers connecting Estela Maris to Avenida Contorno. That's a lot of ground. I mean, sky. It's a considerable distance for an urban drone flight. Yes. And they're not small drones either. They carry up to 10 kilograms. There's a company like Anel Dente for dental implants that has been using them since January, all done correctly with drones certified by NAC.
The NAC certification is crucial, of course. It guarantees the safety of the operation, for sure. And the benefits are obvious. Faster delivery, probably safer than facing traffic, right? No doubt it avoids congestion, and on top of that, with less carbon emission. Exactly.
And what makes this possible is a Brazilian company, Speedbird Aero. They're already an international reference in this.
Really? That's cool? Yes. Their model, the DLV2, was the first one certified here in Brazil for these BVLOS flights. It has a good range, more than 20 kilometers, and that 10 kilogram capacity. And they don't just transport parts, do they? You mentioned they even deliver biological material.
This shows a level of confidence and precision in the operation for the Pardini group, right? To transport biological material, the requirement is high, for sure. But I imagine it's not just having the drone, it needs a whole structure behind it, right?
Exactly. And that's where Salvador stands out. They have 10 regulated points for landing and takeoff, like mini airports for drones, drone ports.
That's it. And defined air routes authorized by the DCE, which controls the airspace. These routes go all the way to Itaparica Island. And what about safety? Flying over the city. They thought of that. Most of the flights are over the sea. This way, they minimize the risk over highly populated areas. That's an important precaution.
Makes sense.
And there's more. Salvador was a pioneer in creating a municipal policy just for drones. They're thinking about how to integrate this into the city's long-term planning.
Wow. That's a real vision for the future, not just allowing it, but planning it. It shows a very interesting strategic vision, right? Logistics truly gaining a third dimension.
And it seems it doesn't stop there. Speedbird is working with Senai Kimatech to develop even larger drones.
Yes, the goal is to reach a 50 kilogram payload and a 100 kilometer range. Imagine the possibilities. Wow. And they want to expand to Linha Verde, Morro de São Paulo, to create an aerial logistics corridor. If we look at the world, Brazil is well positioned in this, did you know? In many places, they're still debating rules, doing small tests. Not here.
There's already commercial operation and a serious expansion plan. Does this mean we might be closer than we think to receiving our grocery shopping by drone?
Well, the question is still in the air, isn't it? How long until this becomes routine? The technology is here, the regulation is moving forward. It seems like they're converging. Fascinating.
Okay, from Salvador, let's take a leap inside our heads. You know that thing where you look at an incomplete figure like a drawing with a missing part and our brain goes and completes it?
Oh, yes, the illusory contours. We see a shape that isn't drawn there. Exactly. Well, scientists managed to find the exact circuit in the brain that makes this happen.
Seriously? How interesting. It was a study from UC Berkeley together with the Allen Institute. They found specific neurons that they called IC encoders for illusory contours. Okay? And how do they work? It seems it's through something called recurrent pattern completion. To simplify it a lot, it's as if more advanced areas of vision look at the small pieces of the image and send a message back to the primary visual cortex saying, hey, complete it, that's a square, even if lines are missing.
I see. The brain kind of projects the complete shape back into the initial visual area, right? And to prove that it was these neurons, they used a technique with a very complicated name, two-photon holographic optogenetics.
Ah, optogenetics. That technique that uses light to control neurons, right? But holographic and two-photon.
That's very advanced, indeed. They basically used super precise lasers to activate only these specific neurons in the brains of little rats, almost like a remote control.
And what was the result? That's the most incredible part. Even without showing the animals any image, when they activated these illusion neurons with the laser, the brain activity was exactly the same as when they were seeing the real illusion.
Wow. So the brain created the perception of the shape just with the internal stimulus. Exactly. The brain saw the illusion just because those neurons were activated. This proves they are the cause.
This is impactful. It shows that our vision isn't just passively receiving light, is it? No way. It's an active process.
The brain interprets, completes, sometimes even invents a piece to make sense. One of the researchers, Jerome Lee Saul, said that understanding this could even help study conditions like schizophrenia, where the brain generates perceptions without having an external stimulus.
It makes perfect sense. And the broader implication is to think, if our perception is actively constructed like this, to what extent is the reality we live in objective, or is it a neural construction that we share, a shared illusion? It gives us a lot to think about.
And speaking of perception and construction, that leads us directly to robots, because we're trying to build something in them that looks like perception interaction.
Exactly, the search for machines that interact in a more human way, right? The image of the cold, somewhat clumsy robot still exists.
But get this, a Chinese company, Fourier Intelligence, launched the GR3, and they're calling it the most lovable humanoid robot in the world. Its focus is social and domestic.
The most lovable, the marketing is strong, huh? For sure. And in the videos, it's not in a factory, it's helping curators in a museum, guiding people in several languages.
Helping out at home, even posing as a model for painting, and they say it reacts with sympathy. Interesting. But how do you create that lovability in a convincing way? It's easy to look fake, right?
That's the question. Does it work or does it come off as weird and forced? Well, according to the company, the secret is in the engineering behind it.
It has a human size, 1.65 meters, 71 kilograms, and 55 joints, which they call degrees of freedom. This helps it have more fluid movements. Okay. Movement is important, but the lovability comes in with what they call a multimodal full perception interaction system. A fancy name to say that it combines several things: vision to recognize faces and gestures,
pressure sensors in the body to feel touch, and an animated face. The eyes blink, follow you, react. So it tries to respond in a more complete way to the interaction.
Exactly. The idea is that the combination of all this creates a response that seems more coherent, more natural, and the design also helps.
They tried to make it less machine-like, more accessible. It even has a fatigue mode.
Fatigue mode, what's that about?
I imagine it's so it seems less tireless, more human in its movements after a while. It's a curious detail, a curious one indeed.
So the focus isn't just on doing the task, but on how it interacts while doing it. It tries to convey a presence or a simulated emotion.
Precisely. And this could be a sign of a change. Maybe the future of these robots is less about replacing us and more about coexisting, offering some kind of social or emotional interaction.
But then ethics come into play, don't they? Is it real empathy? How do we react to this? Exactly. It opens up a huge debate, but the direction of technology seems to be heading there towards this greater social integration.
While this GR3 seeks a lovable interaction, there's another area of robotics focused on autonomy, but in very different scenarios, like the military. Yes, moving from the social to the strategic. Let's look at the Ghost Bats, or MK-28, which they also called the Loyal Wingman. It's a project from Australia from their Air Force with Boeing.
It's an advanced drone. It looks like a small jet, made to operate on its own or semi-autonomously. Ah, the Loyal Wingman. This project is already very mature, isn't it? Years of development.
6 years, and it has already flown about 150 hours in real tests. And the craziest part, more than 20,000 hours in simulation to refine autonomy.
20,000 hours? That's a lot of virtual testing.
And their specifications are impressive. A range of more than 3,700 kilometers, high subsonic speed. And there's the key detail, its nose is modular.
Yes, that's very important. You can change the tip of it for different missions. It can carry sensors, cameras, intelligence equipment, or even weapons. It gives a lot of flexibility. And in tests, they showed that several of them can fly together, coordinated in a swarm.
Swarm operation. Exactly. And also working together with manned planes like the F-35 or command planes like the E-7A, the Weddill, functioning as a force multiplier, right?
In practice, what does that mean? It means being able to monitor huge areas like the coast of Australia for a longer time.
It means responding faster to a threat and giving the commander more tactical options.
I see. More eyes in the sky and more coordinated action capability. And it's not just Australia that's keeping an eye on this. The United States Navy has already tested similar things. Other countries like Poland have shown interest. This concept of a loyal wingman, the autonomous drone helping the human pilot, seems like it's going to become a standard.
For Australia, it makes perfect sense to protect that gigantic coast of theirs. Exactly. It's a bet on technology to reinforce the defense of a vast territory. This coordinated autonomy is truly powerful. Now let's go back to biology and technology. If before we talked about manipulating neurons with lasers, now let's talk about seeing what they're doing in a new way.
Seeing the brain in action. How? With a small device called the Deep Miniscope. It's a tiny microscope that can film brain activity in real time with high resolution. And the best part, with the animal moving freely, without needing complex surgery or being restrained.
Wow, that solves a huge problem in neuroscience, right? Observing the brain during natural behavior, how it works.
The trick is to use, instead of just one lens, a thin mask with more than 100 microlenses. Each one captures the image from a slightly different angle, multiple perspectives.
Then artificial intelligence comes in to put all those images together and create a detailed 3D image of the neuron's activity.
It shows who is firing, how they are communicating, and can see through the brain tissue, which always scatters light, obstructing the image. I imagine that's where the deep in the name comes from. They use a neural network that learns to compensate for this light scattering, kind of seeing through the fog of biological tissue, a combination of AI and light physics, very clever.
And have they tested it? Yes! The UC Berkeley team, led by a researcher named Yi-Yang Gong, got super clear images of a rat's brain as it walked and explored an environment.
Wow, so you can see what's happening in the brain while the behavior is occurring? Exactly. Immediately correlating what the animal does with what the neurons are doing.
The potential for understanding neurological diseases like epilepsy, Alzheimer's is gigantic, I imagine, and they're already making an even smaller wireless version.
Right, 2 centimeters, like a little hat for the rat. With this, the idea of reading minds starts to become less of a fiction, right? At least at the level of basic neural activity. Seeing these patterns in real time is a leap.
It brings us closer to fundamental questions. How does consciousness arise from all this activity? Exactly. It's a fascinating path, and if we're getting close to seeing the mind, will the next step be to try to recreate the body in a more biological way?
How so? It's the idea of cloning robotics. They don't use electric motors.
They're trying to remake body parts like hands and arms using artificial muscles and tendons, ligaments, all kind of similar to ours.
Artificial muscles, how do they work? One of their prototypes, the Protoclone 5.1, already had an arm with more than 200 degrees of freedom and 1,000 artificial myofibers, more than a human hand.
And these myofibers are like rubber tubes with a mesh of fabric on the outside. They pump pressurized water inside. There's a hydraulic system they call a heart, and the tube swells and contracts, pulling the robot's bones.
Hydraulic muscles, but with a bio-inspired design. And the movement becomes incredibly smooth, organic, very different from the traditional, somewhat square robot.
The NeoClone is the newer version of this. And how do you control all that? It must be a challenge. They use powerful chips like NVIDIA Jetson to plan the movement. And each muscle has a sensor to measure force, position, to have fine control. And they're thinking of adding artificial skin too. They were working on that. A skin that feels touch, pressure, temperature.
They took a break, but their vision is this: realistic artificial bodies for prosthetics, for service robots that need to be delicate.
A robot that needs to drink water to function. Where does the line between biology and engineering lie there, right?
Exactly, that's the question. Is this bio-inspiration strong? Definitely.
And there are other great examples, The eels, scientists in Japan at Itsukuba University, studied how they continue swimming properly, even after injuring their spinal cord, even with the communication to the brain possibly interrupted. How is that possible?
It seems the secret is a balance. There's a rhythm that the neurons in the spinal cord can generate on their own in each part of the body.
A kind of local pacemaker, right? And combined with feedback that comes from the body itself. As it bends in the water, the skin stretches, feels the pressure, and this information helps coordinate the movement of the next segment.
So the body feels the movement, and that helps continue the wave. The body kind of takes control.
Exactly. It doesn't just depend on the central command from the brain for every single detail. It's a distributed, more robust control. How incredible is this local autonomy?
And they made a robot with this. They made a long eel-like robot that used this stretching feedback to move. And it worked. It swam, crawled out of the water, avoided obstacles, using mainly this information from its body.
And what's the advantage of that for robotics? Much more adaptable robots that can deal with a changing, unpredictable environment. Think about rescue, disaster, exploring another planet, inspecting pipes on the seabed. It brings nature's flexibility to engineering.
Exactly. The ability to adapt, to keep functioning even with a problem, is real-life plasticity in a machine.
Well, so to recap our conversation today, we went from a drone making deliveries in Salvador, a revolution in urban logistics. We moved on to a laser creating illusions in the brain, questioning our own perception. We saw a robot trying to be lovable and another one autonomous for defense, exploring the limits of interaction and autonomy. And we also dove into technology to see the brain live and into robots with artificial muscles and inspired by eels.
Yes. The thread that seems to connect all this is this increasingly greater fusion of the biological with the technological, isn't it? It's true. On one hand, we create machines that feel, that adapt, that interact in an almost organic way. On the other, we use technology to understand the secrets of our own biology, how we see, think, move.
And this leaves us with a question at the end, doesn't it? Exactly. As this line between the natural and the artificial, the living and the machine becomes more blurred, how will this change our understanding of what it is to be alive? What intelligence is, what is real, and what new responsibilities arise for us?
Exactly. What ethical, social, perhaps even existential responsibilities do we have as we navigate this new hybrid territory? It's definitely something for us to keep thinking about.
This video doesn't end now. It continues with us talking in the comments. If you found this video interesting, I invite you to become a channel member and like this video. Here on the top right side, I'll leave a video suggestion for you to continue with me. I'll see you in the comments and in the next video. See you soon.